In this video, I am going to go over the 5 problem-solving skills you must know for the Chemistry Regents exam when it comes to redox and electrochemistry. This is one of the toughest units that students have a hard time with because it's not just about memorizing some vocabulary words, it's applying some skills to get to the answer. So let's go ahead and get started. Problem solving skill number 1. And this is important because this lays the groundwork for everything else. And that is that you need to know how to apply oxidation numbers for an element by itself and an element in a compound. And here's where we're going to use our periodic table to help. So when I have an individual element and I'm looking for the oxidation number, so for example, let's say I just have aluminum written down, or zinc, or any of the diatomics like fluorine or chlorine. The oxidation number is 0. They're known as elements in their free state, which means they haven't lost or gained or sharing unequally of electrons because they're just bonded to the same atoms of the element. So they're assigned an oxidation number of 0. But now when I have a compound, I have to be able to determine the oxidation numbers for the elements in that compound. So let's take a look. All right, so for instance, let's say I had aluminum Al F3. Aluminum has an oxidation number and fluorine has an oxidation number. The first thing you're going to do anytime you're asked about oxidation numbers is don't forget to use the periodic table for help. So let's just do that. I want to show you what I'm talking about. Okay, so aluminum is here, fluorine is here. Aluminum has only one oxidation number. In fact, there's oxidation numbers in the upper right-hand corner for every element, or at least the elements that you're going to be responsible for. We're lucky that in this case, aluminum is +3 and fluorine -1, so we know the oxidation numbers just by looking them up. Sometimes it's not as easy. For example, look at nitrogen. Look at all the different oxidation numbers that nitrogen could be. So let's go back and take a look at an example of that. So for our aluminum fluoride, aluminum's oxidation number is +3, fluorine is -1. Let's do another one. This was a Regents question where the students were asked, what's the oxidation number for nitrogen? Well, go back and look at the periodic table. You already saw that long list for nitrogen. Oxygen, you only have to worry about -2 as the oxidation number. So, just like when we were writing formulas or naming compounds, electrons lost have to balance electrons gained. So I have 2 oxygens, each one of -2, that's a total of -4. That means if I only have one nitrogen, the oxidation number here for nitrogen must be +4. Since it's a compound, it's electrically neutral, meaning +4 minus 4 is equal, of course, to 0. So you have to be able, again, to assign oxidation numbers. Now, just like with individual elements, the oxidation number is 0. If you're given an ion, for example, let's say you were given Na plus. Real simple, that ion charge is equal to the oxidation number, or Cu 2 plus. The ion charge is equal to the oxidation number, or let's say Cl minus. The ion charge is the oxidation number. So individual elements, oxidation number 0. When I have ions of one element, the charge is equal to the oxidation number. And when I have the different elements in a compound, definitely go to the periodic table and look them up. And if need be, you're going to figure them out by what your positive oxidation numbers and what your negative. Okay, so with that, let's go to number 2. So it's not just about identifying oxidation numbers, it's also applying them to reactions. So for instance, on the Regents, there was a question where you were asked, or the students were asked, what happens to the nickel atoms in this equation? Okay, before we go on, we're going to have here a Ringo rule. This is Ringo, and Ringo is here to tell you that what you see on the screen right now is something that you have to memorize. No doing it off the top of your head, no trying to find it in your cloud. Write it down, use it when you're practicing redox so that you're going to answer the questions correctly. Then right before a test on redox and electrochem or the Regents itself, you're going to make sure you memorize it by practice writing it down over and over again, and then use it on the tests. As soon as you get the test, write this down before you ever start the test. Right, Ringo? He says right. All right, so let's check this out. All right. Yes, we have a number line. So the number line is the change in oxidation number that you might get when you're looking at where you're starting with an oxidation number on the left-hand side of an equation and where you might be on the right-hand side. So as oxidation numbers become more positive, they are becoming more positive because you have an element either on its own as an ion or in a compound losing electrons. And remember, electrons are negatively charged, so becoming more positive. We call that oxidation. Your loss of electrons is going to be on the right-hand side of an equation. So you're going to see it as a product. The exact opposite is reduction. Now you have oxidation numbers that are becoming more negative. Why? Because you have something gaining negative charges known as electrons. The electrons would show up in the half reaction on the left hand or reactant side. So memorize this, write it down. When you're answering questions, either for practice or on the Regents, you want this in front of you. So let's keep going. So I just wrote down the single replacement reaction, and the first thing you're going to do is you're going to apply all the oxidation numbers. So nickel, let me just change the color here, make it easier to see, is by itself. The oxidation number is 0. HCl is in solution, AQ. That means I have hydrogen ions and I have chloride ions. Then on the other side, I have AQ again. That means I have chloride ions, and now I have 2 of them. That makes nickel plus 2, and hydrogen is alone. Hydrogen, therefore, the oxidation number is 0. Now, in the original question, it was asking about which substance loses electrons, and that would be the nickel. It's going from 0 to a plus 2 oxidation number. It's becoming more positive because it's losing electrons. So be careful here, because what's being oxidized is the nickel atoms. And again, the nickel atoms are losing 2 electrons. At the same time, what is being reduced? That's going to be the hydrogen, right, ions that are going to go from plus 1 to 0. So that is what's being reduced. What's losing electrons, whatever's losing is being oxidized, whatever's gaining is being reduced. One of the most important things to keep in mind when you're asked one of these 4 questions, you're dealing with the substances here as the reactants. It's not the products, because it's the product. If it's the products, it's already been done. Something's being oxidized and something's being reduced, and be very specific. In this case, it was nickel atoms and hydrogen ions that are undergoing the changes. You need to practice this. You need to check out more questions. You need to look at other videos that look at some of this stuff specifically. And that's why redox, the unit, is pretty tough. But you can do it. Keep working hard. And let's go to number 3. If you're going to be asked about oxidation or reduction half reactions, most of the time you're going to be asked to identify it. You might be asked to write one, maybe given an overall equation where you apply the oxidation numbers and bring it down and balance with electrons, but more than likely you're going to be asked to identify. So let's take a look at an oxidation reaction, half reaction, and a reduction. So what if I have copper as a solid going to copper ions, AQ? Now, you see 2 electrons on the right-hand side as a product. You have copper atoms going from 0 to +2, losing 2 electrons. Remember Leo, the lion, I'm sure your teacher told you this, right? Leo is loss of electrons is oxidation. So my copper atoms here are undergoing oxidation, and this would be an oxidation half reaction. So it's an oxidation half reaction, you're going to see electrons as a product. The other thing about reactions, redox reactions, the half reactions, and overall, everything has to be balanced in terms of mass and charge. So we start with 0 charge on the left, then we have 2 plus ion plus 2 electrons, which adds up to 0 on the right. Let's look then at an example of a reduction half reaction. So Leo the lion goes Gur. So gain of electrons is called reduction. And what if I have silver ions? Each one is gaining an electron to become silver atoms. You're going to see reduction electrons as a reactant. So on the left-hand side of the table. So identifying or even being asked to write oxidation or reduction half reactions is always on the table. So make sure that you practice your redox questions, and let's go on to number 4. The fourth skill you need to know for redox is using reference table J, and you're going to figure out which reactions, single replacement reactions, will work spontaneously with that table. Redox reactions are synthesis, decomp, and single replacement reactions. Double replacement reactions are ion exchange, meaning that the electrons lost and the electrons gained are not changing. It's just a switching of ions with double replacement. So let's go to reference table J. Okay, reference table J. So what I'm looking for here, if I'm given, let's say, a metal ion, let's say it's calcium ions, and you're given 4 choices as to what can react with calcium ions. Well, here's calcium. Any metal that has an oxidation number of 0, meaning it's just the atoms above calcium, will make the calcium ions gain the electrons while those metals are losing electrons. So for example, lithium atoms plus calcium ions will react. We'll get lithium ions and calcium atoms. The opposite way will not work. In fact, if I have a solution with lithium ions in that solution, no metal I put in there is going to make the lithium go from the ion form back to the atom form. And that same principle works on the nonmetal side. Fluorine is the most active nonmetal. So any of the other nonmetals below fluorine, so chloride, bromide, and iodide, if they're in solution and I put fluorine in a solution with those ions, fluorine will form the fluoride ion and force chlorine out. The other way will not work. So if I have fluorine and I don't have the other elements below as ions, nothing will happen. Now, there's one other special thing with metals on the left-hand side, and that is down here with H2. All of the metals above H2 will react in an acid, and you'll form hydrogen gas, and you'll get the salt with that metal. Below, copper, silver, and gold do not react in an acidic solution. So reference table J, if you're asked anything about single replacement reactions, make sure you check out this table. Okay, we are up to number 5, and that is electrochemical cells. Now, it sounds so easy here just to identify the two types. There is a little bit of information that tends to show up on the Regents exams as far as electrochemical cells. Now, one type is known as the voltaic cell. These are spontaneous if they're set up right. The other type is known as the electrolytic cell. So, for a voltaic cell, you're going to see two containers that are going to be joined by a salt bridge that allows the flow of ions, and you're going to have wires that connect the solutions here that allows the flow of electrons. Now, on one of the last Regents is more recent. I think they tried to fool students because instead of a salt bridge for the voltaic cell, they use what's known as a porous barrier. But you can still pretty much figure out it was two containers. An electrolytic cell, it's all going to happen in one container, and that would include electroplating. So I might have a spoon that I'm electroplating. I know, bad drawings, and I have a power source. Electrolytic means I'm taking electrical energy and I'm forming a redox reaction to happen. So that's electrical to chemical. Voltaic, it is chemical to electrical. Here I am actually producing electrical energy. So either cell, there is something also you want to remember. Oxidation always takes place at what is known as the anode for either cell, and reduction takes place at the cathode for both. Now, the way you can remember that is anox. Sorry for my bad handwriting. Anox and red cat. So if you're asked anything about half reactions, the anode is oxidation, cathode is reduction. And the electron flow is anode to cathode. All right, well, that ends redox and electrochem as far as the skills you need to know. This video, while it is pretty long, might not be enough to get you to answer all the questions correctly. So you're going to want to check out other videos here on my site, NY Chem Coach, and some other sites as well. And just keep working hard and good luck. And I do want to mention that if you heard some snoring in the background, that was my Irish setter Rudy, my 120-pound dog. So he also is just going to remind you, don't get lazy like Rudy and just snore. Make sure you're studying your chemistry. Good luck.